So before we get started, let's take a look at some formulas that are going to be guiding our problem solving process. So title it formulas. All right, first one has to do with area. So the area formula is basically the integral from a to b of the function on the top, let's call it f, minus the function on the bottom, let's call it g. It could be the function to the right or the function to the left. All right. How do we know the orientation? Well, dx basically indicates a top-down orientation. Function on the top minus the function on the bottom. In this case, the slice, the cross-sectional area of the rectangular region is going to be perpendicular to the x-axis. Or dy is a situation where you're looking at a function to the right minus a function to the left. Okay, in that case, your cross-section, your rectangular region will be pointing to the y-axis. Okay, with this orientation, g is less than f. Okay, either g is to the bottom of f or g is to the left of f. Now, volume is a little bit more intricate. Let's take a look at the formula for volume. So volume is the integral from pi times the integral from a to b of the outer radius, big R square, minus the inner radius r square. Okay, that gives us the area of the washer, and then when we integrate from a to b, we can find the volume. Dx is when your radius is perpendicular to the x-axis or pointing to the x-axis, and then the y is when your radius is perpendicular or points to the y-axis. Now there are two scenarios here, depending on the orientation of your axis of rotation. So let's take a look at the two cases. The first one, pi times the integral from a to b. If you're looking at a top-down orientation where top-down or left-right, if the axis of rotation is less than the two functions, we're going to have the function on the top or to the right minus your axis of rotation square. This is big R square. Pi R square will help you find the area of the bigger disk, minus g minus a square. This is little r square. So pi times that square will give you the area of the inner disk, and then when you subtract these two areas, you get the area of the washer. Okay, so dx, if your radius is perpendicular to the x-axis, or dy, if your radius is perpendicular to the y-axis. All right. So this situation is applicable when a is smaller than both functions. Either it's at the bottom of g and f, or it's to the left of g and f. Okay, and then the other situation we have is pi times the integral from a to b of a minus f. This is big R. The difference here is a is bigger than both of the two functions. Okay, so a minus f square will give you the outer radius, minus a minus g square will give you the inner radius. Dx, if your slice is perpendicular to the x-axis, or your radius is perpendicular to the x-axis, or dy, if your slice is perpendicular to the y-axis. This orientation is applicable when f is less than g and g is less than a. It's like a reversal of the order here. Okay, I always like to put f at the end and then put g in the middle and then a at the other end. So this formula is applicable to revolution, solids generated as a result of revolution. Now, how about the volume of solids with known cross-sectional area? That's very straightforward. That one, the volume is simply going to be the integral from a to b of the cross-sectional area. It could be a of x or a of y, depending. So it's dx if the base is perpendicular to the x-axis, or dy if the base of the area is perpendicular to the y-axis. So This is for cross-sectional area. Let's put that note there, cross-section. The only hard part with this last formula is finding the area of the cross-sectional area, because you have to make use of your geometry formulas to find the area.